Improve stormwater management and water quality. When people hear buzz about the green building movement, they often think of low-flow shower and waterless urinals, alternative power source such as a solar or wind, and green power credits. Yes, the green building movement is about all these things, but also so much more. Minimizing the environmental impact of land development also includes protecting natural system, reducing impervious footprint, and keeping stormwater in check. That's where come in the civil engineers. In the green building movement, our roles as civil engineers is significant and multifaceted. It requires us to integrate sustainability goals into every step of design, from site layout and material selection to stormwater management and erosion control. It is our responsibility to study the ramifications of design decision from the perspective of environment impact, as well as cost, maintenance, and practicality. By adopting some of these methods as standard design practice, we can reduce the impact of all site development, not just the projects that are going green.
Stormwater system design. The stormwater arena management, harvesting and quality is probably the most obvious civil engineering contribution to green design. Stormwater models are the metric for quantifying benefit of integrating layout, materials and management to minimize the development footprint. Land development displays nature, so beginning design with a stormwater concept plan is the key to mitigating the effects of the displacement. For example, hydrologic patterns or areas of infiltratable soil should be protected in much the same way as wetland and floodplains. These elements become especially important as more localities move toward adoption of runoff reduction methods, low-impact development ordinances, and the pursuit of U.S. Green Building Council leadership in energy and environmental design certification. Additionally, in recognition of the fact that integrated management practices will never completely replace stormwater management ponds, design that include fall-based aquatic bench and adequate hydrology must be standard for all wet pond design to help alleviate sediment resuspension, temperature increase, and oxygenation issues. Another tactic is that designers are helping green residential development strive to minimize disturbance using site fingerprinting and clustering technique as a means to maximize undisturbed natural areas without sacrificing lot yield. This method also can be effective to decrease construction and grading costs while maintaining natural habitat, reducing stormwater requirement, and enticing residents to experience nature in their own backyards. During commercial or industrial project planning, consideration should be given to balancing green space and pedestrian flow with the minimum parking capacity needed to meet code requirements. Thoughtful design break up parking lot with islands which reduce runoff temperature and enhance the appearance of a development. It is best to design multifunctioning landscaping island by dispersing the grades rather than mounding and directing water through the island to drop inlets. Bioretention and flow through planter have significantly fewer maintenance issues and are more cost effective than sand filter for the same filtration effect. Plus, this alternative has the added benefit of creating habitat and shade.
Studies show that water quality within a watershed degrades significantly as the percentage of impervious surfaces within that watershed increases. As civil engineers, we must balance the need to meet code and the owner's program and minimize the impervious surfaces. Civil engineers should constantly ask, does this area really need to be paved, and if so, how does it need to be paved? Sustainable solutions are plentiful on redevelopment projects, as the civil engineer can option to pulverize all pavement in place to use as subgrade for the new pavement section, thereby reducing projects costs and environmental impact, while also contributing towards LEED materials and resources credits. In other cases, Alternative paving materials such as pervious concrete or asphalt and open grass or gravel system can decrease runoff rates, volumes, temperature, and velocities. If the soil below the permeable pavement are well drained, they can provide an additional infiltration function benefiting water quality. It should be noted, however, that this option do tend to cost more than asphalt lots and also require regular maintenance. We typically see a minimum increase of 15% for installation costs, while the increase in cost of materials usually depends on the type of section designed. Alternative pavement sections are appropriate for low traffic areas such as parking stalls or fire lanes, and it's best not to drain adjacent slopes or islands across them to minimize clogging. It is important to weigh the difference between the cost of the alternative sections and the decrease in storm system and stormwater management costs. One of the Timmins Group's development projects in Richmond, VA, served as a local demonstration area for alternative material selections. The architect owner chose to retrofit one of the existing buildings as a parking garage for their employees and further requested a small surface lot using various styles of pervious pavement for visitors. We added a large green area to the side, a small green roof section, and designed pervious concrete and primer paver in the parking stalls and plaza.
Stormwater reuse. Once the runoff is minimized by site layout and material technique, we can evaluate the benefit of harvesting rainwater for reuse. Surface storage is the most cost-effective containment. However, artistic and biological issues often arise because of constantly fluctuating water level. Underground storage, which costs $3 to $8 per cubic foot, allow for rainwater harvesting without infringing upon a site developable area. However, adequate pretreatment is critical to minimize the potential for odors and frequent maintenance concerns. The cost-benefit analysis for rainwater harvesting has a payback period based on the cost of water in the project region, as well as the use for which is collected, example irrigation, flushing, or potable purpose. Another Timmins Group project, an 11-story LEED gold certified office building in Washington DC, is the perfect example of the impact of integrated design decision. On the roof, an entertainment terrace on permeable paver featured 2 levels of green roof with media volume sufficient to contain up to the 2-year storm. A 5,000-gallon cistern in the basement of the parking garage collect both the condensate water and runoff from the plaza adjacent to the building to feed the drip irrigation system. The cistern also supplies a water filter that flows internally through raised bioretention planters in the plaza throughout the day. The underdrain and overflow drain of the bioretention planter lead back to the cistern and contain an overflow bypass that connects to the public storm drain system for storm events greater than 10 years flow. The cost of this integrated design element was only 3% greater than what have been required to meet code. However, the benefit to the downstream system are invaluable. Erosion control. Erosion control is probably the least glamorous discipline with the greatest impact to water quality. Although it's not permanent, it is critical to the health of a downstream system. If streams are impaired during the construction process, then post-construction water quality measures are important. One of the best services a civil engineer can provide is a thorough, practical, well-designed erosion control plan. Although civil engineers are rarely the ones choosing which site to develop, we must help our clients, owners and developers make informed decisions regarding the environmental impact of development. Each site is inherently different. There is no magic bullet for green design. It is important to evaluate which of our tools will work best for a given site. Consider soils, hydrology, grades, cost and layout, but also environmental benefits, aesthetics and function. For civil engineers to integrate seamlessly into the green building movement,
We must all abandon the idea that each display is distinct and independent. We must rethink our design process to build a more comprehensive and collaborative vision.